All right, so over the last couple of days, you guys have been solving absolute value inequalities. We're going to be looking at some that have special cases. There's a mixture of some that have special cases, and then there's a mixture of some that don't. So as we look through this, you're going to solve these out. Remember that you want the absolute value to be isolated on the left-hand side of the inequality, and then that will help you determine whether this is going to be an and or an or. So with this one, you're going to subtract 3 from both sides. So you're going to have 3 times the absolute value of 3n plus 6 is greater than, and we're going to have 111 minus equals 108. Okay, you're then going to divide by 6. So you should get the absolute value of 3n plus 6 is greater than 18. Okay, so this is where you're going to apply the two rules. When you look at this symbol right here, you can see that it's a greater than, so this is supposed to be an or. Okay, so when we go to graph them, they're going to go in opposite directions. So you're going to keep it and then switch. So the KISS method. So 3n plus 6 is greater than 18. We'll solve that one out. And then 3n plus 6, switch the sign and switch the sign on the number. Okay, so minus 6. So 3n is greater than 12. Divide by 3, so n is greater than 4. Or when you subtract 6, you're going to get 3n is less than negative 24. Divide by 3, so n is less than negative 8. Okay, and then you're going to go ahead and plot those on your graph. So at 4, it should be an open circle. You want n to be greater than, so that would be everything going this direction. Okay, and then at negative 8, it would be an open circle, and you want everything that's less than, so it's going to go this direction. Okay, these are the ones that you should be doing. This is an or, it's what it came out to be, so you can use your interval notation to write down your answer also. So you would have bracket negative infinity to negative 8, negative 8, union with 4, comma, positive infinity. And these would be all parentheses because you have open circles, not equal to. Okay. For number 2, same thing. You're going to solve this out, try and get the absolute value by itself. So we'd have 10 times the absolute value of 5a plus 6 plus 7 is greater than negative 33. So we're going to subtract the 7 first. So 10 times the absolute value of 5a plus 6 is greater than negative 40. Divide by 10. So you should have the absolute value of 5a plus 6 is greater than negative 4. Now, this is one of those special cases because if I look at this, it says the absolute value of 5a plus 6 is greater than negative 4. Well, will the absolute value always be greater than a negative? Yes, always. No matter what value we have for a in here, we can pick anything on the number line and it would always be true. So this one is a special case. The absolute value will always be greater than negative 4. So this technically is all real numbers. So it is everything on the number line. And then your answer would be all real numbers. Okay, this always occurs. The positive value will always be greater than the negative value, no matter what. Number 3, the exact same thing. We got to get the absolute value by itself, read what it looks like, and then see if we can see if it's a special case or if we actually have to solve it out. Okay, so we're going to subtract 4. So we get the 3 times the absolute value of 7 minus n is greater than 6. Divide by 3. So the absolute value of 7 minus n is greater than 2. Now, with this one, you can't tell. This is positive, so you are going to apply the 2 rules. So you're going to keep it the same. So 7 minus n is greater than 2. And then you're going to switch the sign and switch the numbers. So 7 minus n is less than negative 2. Now, with this symbol, this should be an or again. So we're going to see if that comes into play. So they should go in opposite directions. So solve this out. Minus 7. So negative 7 or negative n is greater than negative 5. So n would be, you got to switch the inequality, is less than 5. Divide by negative, flip the inequality. Minus 7, so negative n is less than negative 9. Divide by negative, flip the inequality, so n is greater than 9. And this should be or. So let's see when we go to graph it if it's true and true or. So at 5, you should have an open circle, and it wants n to be less than 5. So that is going this direction. At 9, it should also be open, and you want greater, so it should go to the right. This is a true or, so this is your answer. So n is less than 5, or n is greater than 9. And again, you can write this in your interval notation. So negative infinity to 5 union with 9 to positive infinity. Okay, let's go ahead and take a look at number 4. Sorry, number 4. We have negative 5 minus 9, absolute value of 6 plus 9x is greater than or equal to 22. And again, the very first thing, we need to isolate this absolute value symbol before we can do anything. So we're going to add 5 to both sides, so negative 9, absolute value of 6 plus 9x is greater than or equal to 27. Then we're going to divide by negative 9. That means we have to flip that inequality. So divide by negative 9. So we're going to flip this inequality. So the absolute value of 6 plus 9x is less than or equal to negative 3. Okay. So basically when you're reading this, it's saying if I take the absolute value of anything, it's always going to be less than or equal to negative 3. Well, that's a false statement. There's no way that you can have a positive number less than a negative number. So this would be a no solution. So there's no possible answer for this one. No solution. Okay, and we know it's a special case because we have a negative over here. Okay, we just got to read, well, does it make sense or does it not make sense? This one does not make sense because the negative or this positive on this side will never be less than a negative. Okay, I'm hoping to get through 2 more with you, and then I'm going to have you try the rest on your own, and then I will hopefully be back on Friday for sure. Okay, so on number 9, again, the absolute value is not by itself, so we've got to get that by itself. So negative 9 plus 6 times 2 minus 2m is greater than negative 21. So we got to add 9 to both sides. So 2 minus 2m is greater than negative 12, divide by 6, so we would have the absolute value of 2 minus 2m is greater than negative 2. Okay, so with this one, we got to look at it because we have a nice little negative on this side. So will the absolute value of any number always be positive? Yes. And it will always be greater than negative 2? Yes. So this is an all real numbers. Okay, and again, when you get a negative on this side, that's when you're going to have to check to see if it's an all real numbers or no solution. Okay, and again, to graph in all real numbers, you just shade in the whole number line because everything will work. And you could try different numbers on here. Just plug them in here. Let's try 0. It'd be 2 minus 2 times 0, so that's 2. The absolute value of 2 is 2, which is greater than negative 2, so that works. You could try any one of these numbers and you plug it in for that m, it's going to be completely true all the time. Okay, so let's go ahead and take a look at number 6. Number 6, negative 1 minus the absolute value of 2r minus 10 is greater than or equal to negative 19. All right, so first thing we got to add this 1 to the other side. So we got negative absolute value 2r minus 10 is greater than or equal to negative 18. You're going to divide by negative 1 to get rid of the negative out in front. That means we need to flip this inequality symbol. So absolute value of 2r minus 10 is less than or equal to 18. Okay, so now once you get to this point, I have a positive value here. Okay, so that means I'm going to have to apply the KISS method. Remember, KISS, keep it, switch, switch. Sorry. So you're going to take 2r minus 10, keep it the same. Then you're going to take 2r minus 10 and switch the sign and switch the negative. Okay, this symbol right here tells us that it is an and because it's a less than. So we'll see if this is a true and. So first thing, you're going to add 10 to both sides. So 2r is less than or equal to 28. Divide by 2, so it is less than or equal to 14. And should be add 10 to both sides, so 2r is greater than or equal to negative 8. Divide by 2, so r is greater than or equal to negative 4. Okay, so, and this is an and. So we have, at negative 4, we have a closed circle, and we want it to be greater, so it's going to start going this direction. But at 14, we have a closed circle, and we want less than, so it's going to be going this direction. So you're looking for that and, so it's got to be both. So we're looking for the overlap, which is the middle. Okay, so that is your answer, and then you can write it in interval notation. So negative 4 is your answer, and then it's going to go all the way to 14. And they both should have brackets because they're both included. Okay, so on this worksheet, I would like you to try the rest of them, which, give me a second, and I'll tell you how many that is. So it should be 18 total. So 18 total, and we did 6 of them together. So you're going to try 12 on your own.